Hello, 7.5 is on angle bisectors and parallel line proportions. We are going to use the properties of parallel lines and angle bisectors to write equivalent proportions. So the first one is when we have the proportions on the side of a triangle. So for this one, when these two lines are parallel, RT, so this is going to be a part over TQ, is equal to the parts on the other side also set up as a proportion. So when we write these, we're going to have a part of the triangle over part equals part over part. So what that looks like in an application problem, like number 1, they tell us QS and UT are parallel with each other, and they give us the segments. They want us to find the length of QR, so that's where our variable is going to be. Now the parts that are separated by the parallel lines are the ones that go in the same fraction. So x over 9 would be one fraction, and 4 over 6 would be our second fraction. Once we get here, we can cross multiply to get our final answer. So the length of QR is going to be equal to 6. We can also use this method to determine whether or not two line segments are parallel with each other. So for this one, that gives us on the shoe rack that AB is 33, BC is 27, CD is 44, and DE is 25. And they want us to explain why the shelf is not parallel to the floor. Well, according to the property we just went over, if it was parallel, these proportions on the side of the triangle would have to be equivalent to each other. And if we were to look at these, we can divide the top one by 3 to get 9 over 11, and the bottom one can't be simplified. So because these two are not equivalent, it means the sides are not proportional. Or another way to phrase it, the sides are not cut proportionally. So it's not parallel to the floor. So you can also use this to tell whether or not two lines are parallel with each other. Okay. The parallel line proportions also work when you don't have a triangle, but you just have two transversals cut by parallel lines. And for this, the parts that are, again, in between the parallel lines, like UW and WY, those two would be set up in a ratio together, and then the ones on the other side of the parallel lines would also be set up as a ratio together. So we're going to jump ahead to example 5 at the very end. They want us to find the length of AB, so that's our variable. We know that all of these angles at the bottom are right angles, which means they're all congruent, and because they're all corresponding angles, that means these lines are parallel with each other. So we can use that property we were just going over. So the two values that are on the same side of those parallel lines are separated by parallel lines are going to be in a fraction together. So we can have 16 over x equals 15 over 18. And one thing you want to notice, 15 and 16 are right across from each other, and they're also across from each other in our fractions. They're both in the numerator. So that's one thing you want to make sure is happening in your problem. And for some of these, you are going to get a decimal answer, and that's okay. So 16 times 18, it's going to give us 288, and then we need to divide that by 15 to get 19.2. and that would be the length of AB. Okay, then we're going to jump back up to example 3. And in this problem, it tells us in the diagram, angles 1, 2, and 3 are all congruent. And then they give us a bunch of measurements of different segments, which are all in the picture. They want us to find the distance of HF, which is between Main Street and South Main Street. So looking at our picture, the one length we don't know is GH, and they want us to find the length of HF. And HF is going to be equal to the length of FG. Oh, I don't know why that big line was there. So the length of FG plus the length of GH. We know the length of FG already, 120. We just need to figure out what the length of GH equals. So we can use that property that we've been working with. Because we know angle 1, 2, and 3 are all congruent, and they are corresponding angles, that tells us that these 3 lines are parallel with each other. So the segments that are separated by the parallel lines, we are going to be setting up in a fraction together. Because 120 and 150 are across from each other, those two are both going to be on the top of my fractions. So we're going to have 120 over x equals 150 over 300. If you wanted to simplify 150 over 300 before you cross multiply, you can do that. If you'd prefer just to cross multiply, that is also an option. So then we would get 150x equals 36,000, and then we're going to take that answer and divide it by 150, which gives us our answer of 240. And again, don't forget to go back and answer the question they are asking. They want us to find the distance between Main Street and South Main Street. So we're going to take this answer and we're going to include it in our distance for HF. So HF is going to equal 360, and these were measured in yards. And that's our answer. Okay. So then jumping back up to our vocabulary, the next one is the angle bisector proportion. And for this one, when you set up your proportion, on the top you're going to have the intersected side for that angle bisector, and then you're going to have the connected part that's on the same side of the angle bisector. So you would have AD over BD, and then you would have AD over AC, and then DB over CB. So what that looks like in a problem, let's look at example 4. So on the right side, we know the length of the intersected part is x, so that's going to go on top. Then on the bottom is going to be the length of the connected part that's on the same side of the triangle, so 13. Then we're going to do the same thing on the other side. This time we don't know what the length of this section is, but we know the length from Q to S and then R to S. So we're going to take the total length of that side, 15. And we're going to subtract x. So you would have 15 minus x on top over 7. Once you get here, we're going to cross multiply. Don't forget your parentheses when you have more than one term, so you don't forget to distribute there. So if we take 15 times 13, we're going to get 195 minus 13x equals 7x. Then I'm going to add 13x to both sides. and then divide by 20. So 195 divided by 20. And again, it's okay to get a decimal answer, which is 9.75. And they just want us to find the length of RS, which is the length of X. So we are done with our problem once we get that answer. Okay. If you have any questions on this section, just let me know, and then I will make sure to get those answered.